Thank you. So yes, I'm Matt Aimonetti. My co-founder and I, Steve Marsosi, and I are starting a new company called Splice. And what we do at Splice is that we try to make music better by bringing some of the programming tools into the world of music. So we brought version control, branching, collaboration, and analysis of audio files. So that's what we do. That's what I do. And if you're interested, you can come and talk to me after the talk. I'm also Aimonetti on GitHub. And I've been spending a lot of the years writing code and Ruby code. And during the preparation of this talk, I realized I spent about 17,000 hours of my life writing Ruby code, which is probably not as much as Sandy. But it's a lot of hours. That's about 730 days or 2 years nonstop of writing code. So you can imagine that during that time, I ended up writing and seeing a lot of code, good code and bad code. And I'm the kind of guy who likes to see things from a different perspective. So this talk will be a bit different than usual. The format will be different. Instead of using the entire time slot for myself just to tell you what I believe, I will talk for about half of the time. I will cover about 3 points. And after that, I will invite 2 special guests to come on stage with me and discuss my presentation and the topic we're talking about. And we will take questions from the audience. So please, if you have any questions, think about them, because we'll take questions from you. So what do you guys see when you see this image, this illustration? An empty glass, half-empty glass, half full? I have a tendency to see the half-empty glass. And when I tell that to people, they tell me, wow, Matt, you're very pessimistic. And I disagree with them. They're wrong. I'm very, very optimistic. What I see is a glass that could be full, but not yet. And I want to focus on the empty part to actually fill it up. At the same time, if the glass was full, I have a tendency to think we only have 2 options, drink it or overflow. So I like problems. I like to see the empty part, and I like to see how we can fill it up. So this is why I like to focus on what could be seen as something pessimistic and negative, but it's not. I see potential. So I've been looking at other people doing that, and other people thinking about it in the Ruby space. And I found this quote from Avdi, and he said, the messiest, nastiest bit of mud code I've seen in my entire life was in Rails projects. And that made me think. And I was trying to think about it, and it's true that I've seen a lot of code that was not very, very pretty. I'm not sure that the worst was in Ruby, but I've seen a lot of code that was not very, very pretty. I asked on Twitter, and I asked people to show me code that's bad. And this one guy could not show me the code because it was under NDA, but he told me he saw a Rails controller with over 3,000 lines of code, and a lot of code, a lot of copy and paste. It was terrible. It was really sad, but he could not show that to me. So I did more research. I looked and looked, and I realized there isn't such thing as bad code. Bad code does not exist. You have code that works and code that doesn't work. Really bad code or bad code does not exist. So the way it works is that you have a language designer, in our case, Matt. He will design a language, and this language will have different rules. Now, these rules will be enforced by an interpreter or a compiler that will verify that everything is fine, and then the code will be executed or rejected. So you have code that works or code that doesn't work. But there's no such thing as bad code. If it doesn't work, it doesn't work. Now, it might look ugly, but ugly is different than bad. I went back even further, and I found this quote on the internet, so I'm sure it's true. And it said, code is neither good or evil, but only a place for good and evil. I actually really like this quote. I might have changed a few words, but code is neither good or evil, but only a place for good and evil. And as I was preparing this talk, I went to talk to a linguist friend of mine. And I asked her, can you tell me a bit more about this concept of good and bad, good and evil? And she explained to me that every language around the world has a word to express good. And usually what that means is having a desirable quality, which is an interesting concept. So you want desirable quality. I'm not quite sure what it means for code, but that's what all the languages around the world have a word for that. And they also have a word for bad, which means undesirable, something we don't desire. And it's interesting because as we were talking, she pointed out that there's actually a sense of moral judgment into good and bad. So if it's a moral judgment and it's universal, turns out it's actually not scientific. It belongs, the terms good and bad belong to religion, ethics, and philosophy. They don't belong to science. Nobody will do an experiment and look at the electrons and be like, oh, these are good electrons. I like that. Oh, these are bad electrons. Nobody ever does that. Now, the problem is that I care about my craft, and I care about improving what I do. So I want a way of evaluating the quality of my work. I want to know if what I'm doing is good, even though I cannot say it's good, right? Because there's no such thing as bad code, so I don't know if there's good code. And I was thinking, and then a song came to my mind, a very, very deep song from the Spice Girls. So tell me what you want, what you really, really want. And this is actually the key to everything. This is not about the code. This is not about how we do things. This is why we do things. The reason, and Sandy did a great job with her talk, explaining to us how we got here. People didn't start by saying, well, when you write code, you need to have, what is it, methods are less than 5 lines of code? They didn't say that. They said, we need to build something. And then we came and refined things. And this is really what I realized, like, we need to start by defining the expected outcome. And I'm not talking about how we're going to write the code. I'm talking about why we're writing the code. And this is the first thing we need to do. And we don't need to write code for that. Yeah, you can write tests if that makes you happy for that, but you don't need the test to define the outcome. So you need to think at a higher level than the code. Don't start jumping into the code. That's the first step. Then you need to look at all the solutions that you think could be used to address the outcome. And then get a bunch of them, write as many as you can, like on paper, not in code. Think about them, talk with your friends, talk with your colleagues, and then pick one. Pick one and implement it. It might not be the right one, but it doesn't really matter. Once you pick the one that you think is right, do it. Once you implemented it, you go back to the beginning and you look at the expectations and you look at your code. And you look if you actually match things. And here, what's important is that we're not, again, talking about code expectations. If we ask you to build something that needs to be done by tomorrow, that is actually an expected outcome. If we tell you we're going to have 10 users, if you build something for 10,000 users, you're probably missing the point. At the end of the day, we're not paid to write good code. When I hire people, I don't hire people because they write good code. I hire people because I want them to deliver great products. Now, I would hope that the code they write is supporting the product, and we won't have issues with that. But you're not paid to write good code. You're paid to deliver. You actually should not even think about writing code. Your job is to materialize ideas. You need to take ideas, and you need to convert them into something that is useful for your product. Now, we use code for that. But tomorrow, maybe we'll use something else. Tomorrow, we might be the people who used to use machines, and now we're doing something else. So you need to think higher than the code level. And a way of doing that is actually to sit down with these people that might seem very boring sometimes. The people who talk to you about the ask and the solve and all these weird words that I really don't like. But they are the key for you to understand and for us to understand what we're building, because we're building it together with these business people and with the sales people and all the other people who are involved in the product you're building. And as an engineer, you need to understand these things. You need to understand business objectives. You need to understand timelines, proposition values, the different players. What is the risk factor in this project? Can I cut corners because that's important to meet the deadline, or that's not an option because we know we're going to grow really fast? Now, the truth is, all that is great, but after a while, even if you have really good code, it can turn into emo code. So emo code is not bad code, and I need to explain what it is. Emo code is code that started as helping you deliver on an expected outcome. So you build everything you needed, you have this product, the product is great, everybody is happy, but then something happens. You go back to it a few weeks later, or you show it to somebody else, and people start complaining it's hard to understand. It's hard to maintain. It's hard to scale. Now, this is an interesting one, because people have a tendency to think that if your code is hard to scale, that means it's bad. Well, but again, they're missing the context. Maybe you were never asked to write code that can scale. And often, and I've seen that with a few people, and actually I was guilty of that a few times, you think you need to write code that can scale, but you actually never need to scale it. So you end up spending more energy than needed, and this would be not so great of an outcome. You can write code that's slow because of the wrong technology, because of the way you write code, because you want it to look pretty, or you wanted the code to look pretty, so it's slow. And when you do these things, you end up with people telling you you're doing it wrong. And, you know, I feel really bad when people say that, and I used to say it quite a lot, actually. I was pretty mean. And I realized, well, I'm still pretty mean, but I realized that when people say that, and when I say that, it's really hard for the people who actually hear that because they've been putting all their energy into what they're doing. They're doing their best. And they are, most of the time, delivering. But we tell them, no, you're doing it wrong. This is how we should do it. And it's interesting because I think as human beings, we like to judge other people. We don't like to be judged, but we love to judge people. We walk on the street, we see people, we judge them right away. We judge people giving talks, we judge people with funny accents, we look at other people with code, and we judge them all the time. But we don't like to be judged, so we come up with rules. So we have rules. Rules are great, because if enough of us agree on the rules, nobody can make fun of us. But we can make fun of other people. We can tell them they're doing it wrong. Now, usually rules, to be honest, are not defined to make fun of other people, to protect ourselves. People writing rules usually believe in what they do, and they think it will improve everybody's lives. But other people can pick these rules and use them as weapons to do something else. So here are some of the rules I hear all the time, and people argue with me on blogs or some other places, and they say, well, Sandy said classes can be no longer than 100 lines of code. Sandy said methods can be no longer than 5 lines of code. I like 5 or 6 of the Sandy quotes I get all the time. And I tried something, and you should try. Write a method that's longer than 5 lines of code. You'll get an email from Sandy or Brian Helpkamp at Code Climate. Be careful what you're doing. Another one I heard that's also very interesting is you cannot write good code unless you use TDD or BDD. That's interesting because I really wonder how people were writing code before TDD and BDD. I guess it was pretty terrible code before. So this is an argument, and I mean, I say that as a joke, but we do that all the time, right? When we do code review, we have a tendency to jump to the conclusion and tell people, well, you know what, you're doing wrong because you're not doing it like me. And it's interesting because it's really about the perspective on things. People have different values. They value different things, and they look at it from their own perspectives, and they have tendency to tell people who see things from a different perspective they're wrong. Now, maybe you're both right, or maybe you're both wrongs. But the point is that we should try to look at it from different perspectives so we can get a better picture of the outcome of the project we're building. And this is because we have a tendency to forget that our job is not to write code, but to build things. If we focus more on building things, we focus on the outcome, and then we think about how we do it. But first, we need to think about why we do it. So here are some of the values that people have when they write code. And it's just some of them. One that we see in Ruby a lot is syntax beauty. I remember the first time I picked Ruby, I was like, wow, this syntax is amazing. Like, it reads like English text. Which, I mean, when you speak different languages, might not be a very good argument. But at least the syntax looked very interesting. And when you look at a bunch of gems we have, a lot of the libraries we have in Ruby are designed so the code looks good. So it is really a value of the community that we want things to look good. Look at Rails. A lot of the DSLs are to make the code better than Ruby itself. Because Ruby was pretty, but we think we can do it prettier. So pretty code, a sexy code, a syntax beauty is something a lot of people value. Another one that's very interesting is the abstraction level. In Ruby, the community has a tendency to really embrace the abstraction level. We have a tendency to abstract things at a very, very high level. Other languages don't like that. They prefer to be at a lower level. So it's really a take on things. And I can write the same code, but maybe mine will have less of an abstraction level, and for me that would be good. But for you, it would be bad because you're seeing too much, and that's not really what matters to you. One that's very, very, very interesting is simplicity, because this is the worst argument you can have with anybody. When you show them, look, my code is simple. Simple means different things for different people. But simplicity is something that matters for a lot of developers. Non-patterns. Non-patterns would be, for instance, a gang of 4, or would be patterns that are defined by the community and people recognize them. They're useful because they can be recognized if you know them. So you can understand the intent of the person who wrote the code. Performance. Obviously, if you use Ruby, you don't care about performance. And if you do, you're probably struggling a little bit. But there's ways of writing code that's faster and slower in whatever language you write. But performance is an important one, at least to me. Limited dependencies. So this is interesting. So at Splice, we actually use different languages. So our front end is in Rails, and the back end is in Go, and we have Objective-C for the clients. And we chose to use different languages because we believe that values need to be applied at different levels. And limited dependency is something that scares me personally on the back end. In our Rails app, I think I checked the other day, I got really scared. We had like 60 or 80 gems as part of the dependencies. Granted, Rails is like 20 gems just on its own. But I realized, wow, we have all these dependencies. So if I look at the amount of code I'm running in production for the front end, I probably only wrote a third of it. That's a bit scary to me when it comes to the back end and everything we do. Now, for the front end, a lot of that is HTML generation and other stuff, so it probably doesn't matter too much. But limited the dependencies is something that can be seen as a value for people. In the Go community, it's the opposite. Everything is coming from the language. The standard libraries has everything you need, and I think I have like 3 tiny libraries I'm using, and that's about it. So it really depends on what you're doing. Test first is another one. People feel very strong about test first. In some cases, some people think it's actually not needed. Learning curve. I remember when DHH gave his presentation about Rails, and he showed how you can write a blog in 15 minutes. It was amazing because you could actually do it in 15 minutes, but you could understand what you were doing. That was pretty cool. So the learning curve for people is interesting. Other people look at that and be like, wait, if you can do that in 15 minutes, anybody can do it, it's probably bad. The other thing is fast iteration. Another reason why we kept Rails on the front end, or we chose Rails on the front end, is because you can actually change things really quickly, and that's a strong value. The level of confidence is something that's very subjective, but for me, it's important that the critical aspect of my applications are solid enough that I feel very comfortable knowing what's going on with it. And then I care about robust code. So at the end of the day, you have all these patterns coming, and we all believe in them at different levels. And the problem is we cannot have everything. It doesn't happen. There's not such language. I don't know anything that could just give me all of that. So we need to make sacrifices, and we choose what matters the most for us. And then what happens is that we actually start arguing with other people. And we argue on the wrong things. We try to tell them they're wrong because they disagree with our values. And Amy and I was with Amy last week, and I was talking to her about the code. And Amy, if you don't know her, she's a businesswoman, she's a programmer, she's a designer, she's an amazing person. She's married to Thomas Fuchs, who is also an amazing person. And he wrote libraries such as Scriptaculous, Prototype.js, which really changed the Web 2.0. That was really the beginning of Rails. They're still being used. Like I saw the other day, the iPhone 5 ad online is actually using Prototype.js. And Amy and Thomas, who deliver great products, they're really smart people, get in trouble with other people telling them they're wrong all the time. And I always find that amazing, because for me, Amy is this wonderful person. And people come to her and like, you don't do TDD, you don't do BDD, you're totally wrong, you're doing it wrong. And I'm like, wait, people, just look at what she did. It might not matter the way she writes code or the way she writes tests. What matters is the end product that you've been using and that a lot of people use. So think about it when you have these values that differ. And I think the key to everything at the end of the day is not about code, it's about communication. And communication is not just something we do on a one-on-one. It's also something we do as a team. And I think we need to start communication by talking about the expected outcome as a team. Get everybody together, programmers, non-programmers, define what you're trying to build, and then try to define the team values. Too often, we do that in an implicit manner, a bit like Ruby sometimes, where things happen, you don't really know what's going on, but if you've been writing Ruby for long enough, you know it's happening. Don't do that with your team and communication. Try to be explicit about what you care about. And you might be disagreeing. That's fine. You can disagree. It's not something personal. It's just people need to decide what we do as a team. Focus on building something together, not on the dogma. Get people together, think about it, and learn through this process. Because there's not one person that will come and say, this is the answer, this is what we should be doing, and everybody will agree. You will disagree, then you will agree, then you'll build things, and then you'll change your mind. And things will keep on evolving, and you need to keep track of that, and you need to work as a team. Now, if you're a developer on your own, it's harder, because there's nobody to challenge you in your thoughts. But what I want you to think about is every time you write code, don't think about how you write the code. Think about why you're writing the code. And this is, for me, the most important thing to do. So I'm at Eddie on Twitter, and I want to invite Sandy and Katrina to come on stage with me and discuss a little bit this topic, because they have very interesting opinions. And I hope they disagree with me, so we can have an interesting discussion. And we would like to also take questions from the audience. So maybe you could introduce yourself really quickly.
Hi, I'm Sandy Metz.
Hi, I'm Katrina Owen.
All right, well, that's good, I guess.
Hang on, I'll introduce Katrina. This is Katrina Owen, the person who gave the therapeutic refactoring talk, and a voice you probably hear weekly on the Ruby Rogues. She's awesome.
So the first question is, do you have any specific comments about the presentation I just gave?
I was going to say, yup.
I was hoping you would disagree a bit more.
Duh.
Oh, okay.
It's exactly right. I agreed with everything you said.
Yeah.
Okay.
Now, how are we going to have a controversy?
So Sandy, since you have the mic, as I said in my talk, a lot of people use what you said. I think it was actually not even in your book. I think it came from, was it an interview or something like that?
It was on the Rogues.
Okay, so it was on a podcast. And they use it in arguments all the time. How do you feel about that?
So 30 seconds of context. I was consulting at a company where they had multi-thousand-line models and controllers, and they asked me for guidelines. And the teeter-totter at their shop looked like this, right? And I put a bunch of weight on the other end with the rules. I gave them very tiny constraints. And then I confessed that I had done that online. And I gave the context. And then the rules went around the world. It was, and the most interesting thing to me about that phenomenon was how desperately people seemed to want them.
Yeah.
And so they're useful, but I mean that they're useful in that way, right? Is 101 worse than 99? Come on.
So Katrina, you're actually teaching Ruby, right? You spend a lot of time teaching programming to people. What do you think people need the rules for? Why are the rules so important to people?
So when you're very beginner at something, you don't have any context. So you can't make your own decisions about what is good or bad or useful or going to be productive based on any experience. And so having rules gives you a way to make progress without needing the experience and the context. And through following the rules, you gain that experience, you gain the context, you realize that, 101 isn't actually such a bad number for the length of a class. You realize that the rules are actually arbitrary and context dependent, but it takes quite a lot of experience to be able to make those decisions on your own and to weigh the rules against the forces that are pushing against you.
Sounds good. Do we have a question from the audience? Yes. All right. Can you just come in front? It would be easier.
So this is just an observation from doing a number of different companies across many different languages, but especially recently with fairly complex Ruby on both backend and Rails programming. And it just, I mean, it does boil down to why you're writing the code, but also boils down to a distribution of expectations about the future, right? Because you would write the code differently if you have a different distribution of expectations. Communicating that is almost impossible. So the root cause of most of the refactoring pain or bugs I've seen is actually misunderstanding either of specific requirements, which is far rarer, more likely a mismatch of expectations about the future. And so to me, the problem with some of the many rules about how I write code in the now are that they actually force a lot of people to spend way too much mental energy refactoring for a point in time, which turns out to be mostly relevant over time. And so I'm wondering, what have you discovered, anything useful you've discovered about actually communicating and getting people on the same page about the sort of distribution of possible future outcomes?
It's hard to figure out where to start on this one. I have a lot of discussions with people where they make their argument about why code should go in a specific direction based on some imaginary future. And I try to bring the conversation back to look at the code that we have right now. I see duplication. I believe that we will be well served by reducing this duplication now. I don't know if this class is going to go in this direction or this direction. I don't know the future. I can't tell the future. But I try to bring the discussion back to the code we have, and making choices that are not too expensive now, but also allow us to make choices later.
I'm just going to say that same thing in different words. So I have written. I have lived long enough to be completely confident that every choice I make will be proved wrong. I know that. I'm always wrong, and so guessing the future and writing code for that never turns out well for me. But what I am completely confident about is that something will change, and I can't predict what that thing is. And so my goals about writing code are to write. My absolute requirement is to not write one line of code for every line of code I write has to be for a delivered feature right now, and I try to arrange that code so that I give myself the most space to move as unexpected changes come in.
Does that mean that you don't refactor?
I do a ton of refactoring.
Well, so how do you match the refactoring with the features?
I write crappy code based on TDD, right? I figure out what the feature is, and I write code that does that feature, and then I look at it and I say, if I never expect to come back to it, if it's a script, I just walk away from it. Shut the cabinet door. If all the Tupperware falls out later, we don't care, right? If I'm never coming back, I don't care how bad it looks. Just don't look at it. But if it's code that I have if I have good indications that I'll have to change it again, what I do is I try to make it so that I can understand it when I come back. And that's my refactoring part. I go through and fix all the names, and I often break things into smaller pieces at that point, and then I check it on because in 6 months I'll have amnesia, and I don't want to be cussing about that fool that wrote this code that's incomprehensible. And I leave it.
Yeah. So one of the things that you mentioned readability or understandability, and that's completely context dependent. So if you know that you are going to be working on the code, your readable code, that's going to be completely different than if you're a senior engineer working with 5 junior engineers. You're going to have to make a lot of very different choices in that case.
If you have questions, because we only have one mic, can you just tweet at me? I have my phone, so I'll look at the tweets if you have any questions. I had a question for you, actually. So how much of your time do you spend refactoring versus writing code?
I refactor all the time in tiny little bits. Like I never get very far.
So you don't write a bunch of code and then refactor for 2 hours?
Oh, no. I mean, I write a little code and then I refactor for 5 minutes. And
so
then
it's almost part of the
normal every time
process.
Every time a test runs green that was red, then I sort of take a step back and look at the code and say, okay, now that I have a wall at my back, which is that green test, what's the most simple, straightforward way to express my intention in this code?
So you're basically cleaning up.
I clean up all the time. And actually, Katrina and I've had the good fortune to do some, at least talking about code with Katrina lately, and everybody's different, and having a new pairing partner has made it clear just how, like, I'm intuitive and pain-driven, and I have a hard time expressing what it is I don't like about code, but very often I'm just like, I hate that thing, I'll fix it.
Right.
And I can't really justify it.
Katrina, I know you started doing some Go recently. And it's very interesting to me because, one, you're teaching Ruby, you're teaching programming. Two, you're already a programmer for many years, and now you're starting a new language. How was your experience as somebody who's teaching programming, you learning a new language? Can you tell us a bit more about that and about code quality in this context?
So first of all, I feel just as stupid learning Go as my students learning Ruby. And it's a humbling experience, and I think it's good to be reminded of how difficult it is to be a beginner, and I think we should do that often. I absolutely love Go. It's very, very different from Ruby, and I love Ruby. Ruby has this wild Baroque expressivity, like it's more of the Shakespearean type of prose, whereas Go is the Zen koans. It's very small, it's very succinct. I saw on Twitter someone today complaining that they didn't like Go because they read through the tutorials and the variables had single letter names. And I was like, it's context. In the Go context, the language is very succinct, the code is often very small, and so the scope is very small, and there are very different idioms. You don't have enough context reading through a tutorial once to know whether or not a single letter variable name is a good choice in a language. I like it.
So Sandy, you also have experience with other languages. Ruby is a language that gives us a lot of freedom. Do you think that's causing some of the issues we're having? Because maybe if the language was less open, maybe we would argue less about how we should be writing code. Like in Go, we have a tool that reformats all the code for you. And you get all these things, other languages that basically tell you there's only one way of doing one thing. That's a big thing in Python. It's like you should only have one way of doing one thing. In Ruby, you have 1,001 ways of doing one thing. Do you think that's potentially a problem, and that's why we need rules?
With great power comes great responsibility. I wouldn't give it up. I'd love it. I love being able to do whatever I want. You know, and I came from Smalltalk, so I don't think, well, I've actually finally been talked out of ripping the base classes open and adding methods. Like, people have finally stopped me from doing that.
Wait. You're talking about the good code and bad code now. I'm not asking if it's good or bad. I'm asking do you think that's why we need so many rules, and this is why we're arguing as a community about the rules?
I think I want to kind of beg the question, right? Are we arguing as a community about rules? I mean, to me, that the discussion that the Ruby and the Rails community is having, the Rails community especially is having right now about idioms and design, right? Basically, like, okay, now we've all got these our Rails apps have grown up, we have big balls of mud, and now we have to learn the next thing. And so I don't perceive it as so much a fight about rules, but a transition of a community. A bunch of people who didn't come through computer science school are now all learning the next thing. And I think that's totally cool. And we'll figure it out, right? We'll bang heads until we get better at it, and we'll all learn together.
So how do you deal with working with people who don't see things the same way as you? Because I'm sure that happens.
My
right?
goals are the same as yours. Like here's what I tell people. I'm trying to reduce the cost of getting software out the door. And I'm willing to accept any code that does that. That's my sole criteria.
So concretely, what does that mean? Like, if somebody in the audience is thinking about having the same issue and they're struggling with other people having different opinions on how to write code, how do you personally solve this issue?
I definitely get in a situation sometimes where my only advice to people is make small things, right? All of my advice boils down to that. And then people tell me I don't see that as a way to save money. Prove to me that I will save money. And then at that point I say, I wish we had metrics. Like, how do we measure? How can we get an empirical measurement that determines what strategies are correct? And the truth is that most of us who've been around a long time, we just think we know, but we're making it up.
Right.
And so what I tell them is, I tell people, divide your app in half, take a little section and do it my way for a while. Do it intentionally, make small things, and then if you don't convince yourself, go back and do it however you want. I believe that I'm right, and I believe that your experience will prove it to you. But I'm willing to be wrong. I learn the best way to learn something new is to be wrong about an old thing. So I'm willing to be convinced by data. I'm looking for data.
So you probably have the same experience between pairing with a bunch of people and also working with students. How do you deal with two people having different perspectives on how to write code?
With students, it's very different than working with peers,
Right.
because I pretend that I'm right with students. I tell them that I'm right. I will lie to the students to their face for 6 months, because I believe that it will help them ignore all the complexity of it and just learn enough so that they can go make better choices.
Do you think that can be a problem later on?
No.
So how do we deal with people that take Sandy's quotes and use them as a Bible? Or your quotes, I'm sure that your students will come and say, Katrina said this.
You have to be testing,
Yes.
because Katrina said so. You have to refactor. I don't know. I sound very convinced that I'm right a lot, and I'm very quick to change my mind if I get, again, data.
There was a quote we heard in Baruch. What was it about? Strong opinions weakly held.
Can you bring the mic?
Strong opinions weakly held.
Right?
And that's a quote. I didn't make that up. I mean, here's the deal. The novices don't know enough to stay out of trouble, and they need, like, the thing that people tell me about the rules that I ask them, okay, why do you like these rules? Really? Why do you like them? And what I hear is two things. Some people say, it's wonderful to have a line. There's a place where I know, okay, when I don't have to even think about it until I get to here, and then I stop and think. And now I always know where that line is, so I can always make a choice there. And that was really interesting to me. The other thing is a thing that I don't really believe in, which I'm kind of being convinced about, which is that notion that constraints cause creativity, which I kind of hate that phrase, but you hear it all the time. And people are telling me, oh, my code is really different now that I'm trying to obey that constraint. I'm making objects, I'm doing more sort of things where stuff is separated so that I can make independent change in objects without breaking my whole app. And so I hear those two things. When I don't know, right? I told some people in San Francisco that they should do this, and then I confessed it on the air. And now what I'm doing is going around and every time someone mentions the rules to me, I ask them, how are you using them? In what way are they useful to you? And so I'm hearing those two things, like the bell that goes off and being more creative.
One of the most interesting things about Sandy's rules is that a lot of people got them wrong. So they made up new rules, and it worked really well for them. And so part of the lesson in that, I think, is that just the agreement that we will follow a rule together, we can make up whatever rule it is. It's completely arbitrary, but the willingness to pay a cost for some greater good can be of great value, I think.
Right. So we have a question for Michael. Michael says, I love TDD. For a long time, though, it was the only way for me. Ideas evolve and trying to find balance. How have your views on TDD evolved?
I don't know if they have. I use TDD because I'm not smart enough to write code without the tests to help guide me.
So I am. So let me talk about that. I don't mind. So actually, I was very, very big into TDD and BDD, and I realized that in some cases, it becomes a mental blocker. So I believe everybody should start by doing TDD and BDD because I think it helps you think about the outcome. And what I want is when I write code to first think about what is the end result. And when I was working a few years back with Yehuda Katz on MERB, I remember we had a way of writing first the end result. So we were writing like the API of the code. And we're like trying to refine this API. The code was not working. We were just trying to work through the end result. And then from there, we started saying, OK, can we now implement that? Does it make sense or not? And we would do that. And this is why TDD and BDD was really useful for us. But also realize in some cases, I'm not quite sure what I want yet. And I need to experiment with it. So I'm not as strong as I used to be. I believe in most cases, it's easier to do TDD. I think it is. But I'm also not very strict about I'm going to write a feature, it's going to fail, and then it's going to pass, fail, pass. I'm not like that. It's not the way I personally see code.
I'd actually like to riff off of that. In June, I started an experiment to automate some of the things that I was doing for my students. And I worked maybe for about a week, very, very few tests. And I launched it, and then 3 weeks later, it hit Hacker News. And so suddenly I had this code base that is actually not readable, not easy to... I made a bunch of choices that are, in hindsight, not very good choices. Of course, I mean, I had no idea that people would use it.
Right.
So now I'm making different choices. I am doing so many experiments in that code base that I have very, very low coverage because the tests don't help me stay safe. The tests would just lock in experiments that I don't necessarily want to keep.
Right. There's another point is that in Ruby, I think we actually have to write a bunch of tests because the language is a bit dangerous. And we were talking with Brian Lies yesterday about that. It's like, in Ruby, we don't have a concept of an interface. So we need to actually implement the interface in test to make sure that things are working. When you switch to other languages, I don't know what's your experience with other languages and testing, but I realize the way I write tests in other languages, especially if they're typed languages, is very, very different.
I'm sure it would be, yeah. So I want to back up to the original question about how your ideas about TDD changed.
Okay.
At first, when I first started trying to do TDD, I thought it was a cruel joke being played upon me by smart people, because I was really bad at it. I thought of myself as a very productive, quick programmer, and then my productivity went to 0 overnight when I started trying to do TDD. So it was painful to learn, but I persisted. In some ways, it was a rule that I didn't understand, that I was cargo culting.
Right.
And I when I got through it, because of trust in, I persisted because I trusted those people.
So you were really motivated to succeed.
I was really motivated to succeed. And so, but now...
Can you just tell us why you were so motivated?
I believed those people were smarter than I was, and that I believed that it would reduce my cost of delivering features.
So what convinced you of that?
I got better at it.
So you really put trust in the fact that you would be better, and you put your energy in that, and
it just feels like all these things. Like, why do you learn Go? Like if you're not the one, if everything that we do because we heard someone say it was good, there's an element of faith in that. And then we, because they also told us to mock everything, and everybody learned that was a bad idea, right? So anyway, I did it on faith.
Right.
And then I discovered, I think, 2 things. I think I know 2 things about TDD. One is that tests are the first reuse of code, and that if you cannot test your code, you cannot reuse it. And that for novices who don't know much about design, writing tests first is a way to ensure that code is at some way reusable. And that has value.
But you can write the code just after. You can implement your method and then write the test just after.
I think if you're a novice, you might find...
Isn't it hard to write tests when you don't know how to write tests?
Yeah, it's
so you have to learn how to write tests.
I've had people tell me this. They've said, I don't know what I'm going to do, so I don't know how to write the test. I'll just go write the code. It's hard. There's no doubt about it. But I think tests have value, in that if the tests are hard to write, the code is going to be impossible to reuse. And if you tell a novice, you have to take this step first, then you know that they're going to get reusable code out. Whereas if you let them just go write code, it'll look like all the code I wrote years ago, which means that it's impossible to reuse and impossible to test later. So it has value, but once you grow past that stage, then you're grown up, right? You can do what you want.
So we have actually a question related to that, and maybe Katrina, you can answer this one. I'm a sole developer in a small startup without many years of experience. What coding practices would you recommend? And I think that goes back to what you were saying too. But
Write small things, make small things.
So do you have examples? Going from not writing any tests, going to TDD, it's a big jump, and it's hard, right? And especially when you need to deliver value. So it's not a small thing. What are the small things that people can do to help them improve the quality of their code?
I am never as smart alone as I am with someone else. And even if I were in a small shop writing code by myself, I would find someone and make a bargain that I could trade with them. Once a week, I'll pair on your stuff. On Fridays. In the morning, we'll do my stuff. In the afternoon, we'll do your stuff. We'll code review each other's things. Like that, having another set of eyes. The 2 of us are more than the sum of our parts.
That sounds good. Maybe Boston RB could set that up. They should set up a way of maybe getting people to exchange. Maybe Boston RB could find a way of people coming together and exchange a few hours. I think that's a great idea.
Best way to
I would exchange 2 hours against 2 hours, and you help me and I help you. That sounds like a good idea. Just before, what's that?
We do that.
You do that.
First Tuesday of the month, we do that.
So first Tuesday of the month.
Yep.
So you have to be in the same location.
Thoughtbot's office.
All right. Thoughtbot office. Everybody should go and actually have an exchange of code and see. Let me quickly see if we have a last question. Can we do a last question? Okay. Wow, we have a lot of questions we cannot answer right now. I feel a bit bad. So somebody's asking, what would constitute good communication? You communicate all day long. So how do you?
And then I go hide in my cave for days.
I mean, you've been very efficient in communicating. I mean, both of you have been very, very efficient at communicating your thoughts through other people. How do you manage to do that? Is it just something you were born with, or were you bad at it at the beginning?
I'm terrible at it. I'm still pretty terrible at it. I practice a lot, and I work really, really hard at it. One of the things I think that has helped me a lot for communication is going back to the desired outcome, not talking about how things were last week, not talking about what I believe right now and what you believe right now, but where we are trying to go. That, to me, can turn around a really complicated communication situation and let both parties move forward.
So just get rid of the ego and try to work on the outcome, if you can.
I firmly believe that if there's a miscommunication, a technical miscommunication in a training situation, the problem is not with the receiver, it's with the sender. And as soon as you take responsibility for doing whatever it takes to convey the thing to the person that you're trying to teach them, it's your fault if they don't understand. And that changed everything for me, right? Because my teaching style doesn't suit everyone's learning style. And so now I would just change strategies. Like, take responsibility for the communication, and then everybody communicates.
Thank you very much. That was Sandy Metz and Katrina Owen.